Good afternoon, all.
Good afternoon, sir.
We'll start in 2 minutes. Okay, we will start. Only 15 students are there yet. One second. Is it audible? Okay, we will start. Uh, Now today we will start with the unit number 5. As you can see in the unit number 5, and this is lecture number 1. We will call it as a U5 L1. Unit 5, lecture number 1. This unit number 5 has limited syllabus. You can see I have pasted the syllabus from the syllabus book, and it consists of forces on image bodies and a compressible flow. First part is a forces on image body, where we will deal with different types of forces appearing on different solid bodies when we insert those bodies in the flowing fluid. What is meant by lift, what is meant by drag, what is meant by drag on flat plate, and what is meant by drag on aerofoil. This thing we will learn. In this, first we will start with the first point, that is forces on image bodies. In the previous lecture, we saw the concept of boundary layer formation. Boundary layer formation is a result of formation of thin layer around the solid body when it is inserted. At that time, we didn't studied about anything related with the forces. Now, when fluid is flowing over a stationary body, then a force is exerted by fluid on a body, and when body is moving in a stationary fluid, force is exerted by fluid on a body. Means, if suppose this is a flow, and in that flow, body is moving, means uh, force is exerted by fluid on the, means what, fluid is flowing. In this flowing fluid, I have inserted one solid body. Then force is exerted by fluid on this solid body. This force is exerted on this solid body. But in other case, if suppose fluid is stationary, it is not moving. Sorry, fluid is not moving, it is stationary. And in this stationary fluid, if solid body which is moving is inserted, then force will be exerted by this solid body on the fluid. If suppose both are moving now, both are moving. In that case, what will happen? Tell me. If suppose body and fluid both are moving with different velocities, different velocities. Then what will happen? If both are moving, any idea? Solid body is moving with some velocity. Fluid is also moving with some velocity. Then what will happen? Who will exert a force on where? Any idea? In that case, fluid flowing over stationary body or bodies moving in a stationary fluid, what will happen? Force is exerted by fluid on a body. In that case, force will be exerted on solid body by fluid. This is important. Some examples. You can take example of flow over a building. This is a building and air is flowing. Then we can take example of bridges. Water is flowing and it is getting interacting with the bridges. Similarly, best example we can take as a submarine, ships, aeroplanes, automobiles which are moving in the air as well as. If we take the example of aeroplane, then we can consider it as a solid body moving in the flowing fluid. Similarly, ships and submarines we can take as an example of solid body moving in the liquid, or it is a water. So the main aim, main objective of this subject or of this unit is to understand, means at the end when we finish this unit, what you should know. Here we should know what is mean by drag, what is mean by lift, and how they are working together. How drag and lift will work together and how it will construct a combined effect, while you will later study in higher classes the concept of flight mechanics and all other things. So basics of aeronautical starts with this such type of points which we are dealing in the fluid mechanics. So our point will start from force exerted by a flowing fluid on stationary body. So what is the condition? This first condition we are considering, where there is a flow similar to the boundary layer and that flow has uniform velocity u. In that flow, we are having one solid body, and this solid body is stationary. It is not moving. We have considered aerofoil shape solid body. When fluid will exert force on stationary body, what will happen? There is a exertion in the form of force. There will be a force which we will call it as a total force, or we call it as a resultant force. The total force exerted by fluid on the body is perpendicular to the surface of a solid body. Total force is inclined in the direction of motion. Always it is in the direction of motion. Means this force which is perpendicular to this solid body is inclined to the direction of motion. So later what we can do, we can resolve that force into two components. Two components, one will be in the direction of motion or it is in solid line, and one will be in the perpendicular to the direction of motion. We can connect that, means this is the resolution. So in the direction of motion, in the direction perpendicular to the motion. This is FD, this is FL. Means what? The component, that is first component, which is called as a drag. The component of total force, it is component of total force, that is FR, in the direction of motion, and it is denoted by FD. Drag is a force exerted by fluid in the direction of motion. This first definition come into picture. Then second is the lift. It is nothing but the component of total force Fr in the direction perpendicular to the motion, and it is known as lift, and it is denoted by Fl. So is it clear what is mean by lift, what is mean by drag? Is it clear? What is mean by drag, what is mean by lift? So let's have a poll. Just a minute. One minute. So I will have one poll. We will have one poll rather. So regarding what we have seen, there will not be any mark. Now I'm going to present another screen for which you have to give the answer. I'm sharing one link. Link is there. I need the answer. Yes, I got one answer. Open the link, give the poll. Poll is shared with you. I got only one answer out of 20 students, 18 students. 4 answers. Sushmit had joined just a lecture. Once again, I am sending the link. Question is, drag means what? Perpendicular to the direction of motion, in the direction of motion. There are 2 opinions. You should have some opinion, not like in a class. It is anonymous poll. I don't know who is giving what answer. Once again, I will share my notes, which I am writing on the screen, so that you can see the correct one. So this clears how attentive you are, how I am getting 50% poll. Who is correct now? 16 answers out of 24 are sleeping, I think. Then 9, 8. Just give the poll, come back to the screen of class so that so I got 17 answers. Okay. I will stop sharing now this, and poll will also be closed. %53 students are saying in the direction of motion, and 47% students are saying in the direction perpendicular to the motion. So let's have correction and check who are correct. I will stop once again and I will share back the window where I was dealing with. So here is the concept. Once again, I am telling you. It is nothing but there are 2 components of forces. One component is in the direction of motion. One component is in the direction perpendicular to the motion. The drag is component of force in the direction of motion, and that was the correct answer. Lift is the component of total force in the direction perpendicular to the motion. These things you should clear. Now you only people know who has given what answer, because I have taken that poll as an anonymous poll. I don't know who has given which answer. But check yourself, because now total ESE end semester exam will be having more weightage of unit number 5 and unit number 6. So be punctual about these 2 units. Most of the syllabus will be based on these two units only. So be careful and be attentive. So we will move forward regarding with lift and drag. So as I said, lift is a force exerted by fluid on the in the direction perpendicular to the direction of motion. Lift force occurs only when axis of the body is inclined to the direction of the flow. If axis of the body is parallel to the direction of flow, then lift will be zero. Why it is so? If suppose this is the solid body and it is in the direction of flow, then there will not be lift force. Lift force will not be there. Only drag force in the direction of flow will occur. Means to have lift force, the axis of the body should be inclined to the direction of fluid flow. This important point you should remember. Axis of the body is inclined to the direction of fluid flow. Then and then only lift component, this lift component will occur. Otherwise, only drag component will be having. If suppose fluid is assumed to be idle and body is the symmetrical like sphere, then what will be the condition? Idle fluid and sphere. So drag and lift. What are the conditions? Now tell me the answer. What will be the value of drag? What will be the value of lift in this condition? As I said, if axis is not inclined, then lift is zero. That is one condition. Now idle fluid is there and symmetrical body like sphere is there. Then what do you think? What will be the condition? In that case, drag is also zero and lift is also zero. Both the forces will be considered or will be resulted as a zero. Moving further, just a minute. कहाँ पे सर लेक्चर चल रहा है. So we will have to find out the expression, that is derivation for drag and lift. Expression for drag and lift. For that, what we will do, we will consider an arbitrary shape body. Means this is a solid body with some arbitrary shape. On that solid body, remember this derivation is important again. U is the velocity. Due to that force, again here we will get a total force Fr. That total force, we have two components, Fd and Fl. These two components are in the direction of the motion and in the direction perpendicular to the motion. Then we will consider a small element here. Here, small element of solid body we will consider, and its area, it is like this, and its area is dA. I will not write here, I will write down. dA is the area of that small component. the forces which are acting on that component we will see. For that, we will consider the directions. So one direction which is passing through the center is XX section. Then the different forces acting on that surface area dA. Forces we will consider. So first force, pressure force acting in the direction perpendicular to the surface. So here on this surface, pressure force will act, and that will be in the direction perpendicular. P is the pressure. As we know, first is the pressure force, and it will be due to pressure P, and that pressure P is acting on dA. So total pressure force is PdA, and it is perpendicular to that surface area. Then there will be shear force. Shear force will be acting along the tangential part, means it will be acting in this direction, and that is tau 0. Shear force is acting as a tau 0, and that shear stress is acting as a tau 0 and multiplied by area, that is shear force. That is second is shear force. Shear force which is tangential T tau 0 into dA. Then consider this angle theta, angle made by force with the horizontal direction. Sorry, this is not, this is theta. Theta is angle made by pressure force to horizontal. So what will be the drag force? First is drag force from this diagram. So according to the definition, the force on the elemental area, drag force, all the components in the direction of flow. So we are considering that small element. On that small element, we are calculating the drag force. So force due to pressure in the direction of motion. Force on dy, sorry, dA. So first, what will be there? The component of pressure force in the direction of motion. That is force due to pressure in direction of fluid plus force due to shear stress in the direction of fluid flow, fluid motion actually. So what will be the answer? Force due to pressure means component of this PdA in the direction of motion. काय असेल त्या PdAचा component in the direction of motion? डायग्राम वरनं सांग, त्याशिवाय मी पुढे जाणार नाही. Component of PdA in the direction of motion. If theta is the angle, I want this value, this component. काय असेल? I will wait.
PDA cos theta.
PDA
Cos theta.
PDA cos theta. Correct. The PDA cos theta. Then second component,
Sin theta.
uh, force due to shear stress in the direction of motion, means this component, this the component of this tau dA.
Tau theta. DA cos theta.
No, this is not theta, this is 90 minus theta. If you observe the diagram correctly, then this will be 90 minus theta, because here angle is 90. Okay, means total angle is 180, and that 90 minus theta will be the remaining angle. So the final answer will be here, just see, plus tau 0 dA 90 minus theta. So what will be the simplification? PDA cos theta plus tau 0 dA sin theta. This is for this small area. Total drag. Total drag will be calculated by considering the integration. Means integration P cos theta dA plus integration tau 0 sin theta dA. This is the expression for the drag, simplest expression. The first term, this first term, it's called as a pressure drag. Remember these words from the point of oral also. This is nothing but pressure, pressure drag. And this is known as friction drag. Friction drag or skin drag. Remember these words. Friction drag means what? And skin drag means what? Is it clear? Is these two things are clear? Once again, just look at the expression. We have the solid body. On that solid body, overall force is acting Fr. These are two components. We want to know the value of FD and FL. For that, we consider a small elemental area. On that small elemental area, two forces we consider. One is pressure force, another is shear force. And we found two components in the direction x, in the direction of motion, with concept of the PDA in the direction of motion, tau 0 dA in the direction of motion. Adding both, we got these two equations as a simple equation, these two equation, and taking the integration, we have these two components which are called as a pressure drag, another is called as a friction drag. These two components we have to consider as a total drag. Then the concept comes the lift. So anyone tell me the lift force? Lift. That is FL. So what will be the FL? We will have same diagram, same concept, only the concept is the force due to pressure, force due to pressure in the direction perpendicular to the direction of motion plus force due to shear stress. All things are remaining same. Shear stress in the direction perpendicular to the direction of motion. So equation will be what? Check it out. When we resolve this into two components, one we have seen this, now this and this, these two components, this and this. What will be the value? Tell me. From diagram. First component is first component is what will be the
DDA sin theta.
yes PDA sin theta. The first component is, but what will be the direction? Direction is downward. This direction is downward, so that we are considering it as a minus. And second component is this, which will be in upward direction here. It will be in upward direction. When we resolve this component into two, this will be in upward direction. So it will be having positive sign, that is tau 0 dA sin 90 minus theta. So final answer will be minus P dA sin theta plus tau 0 dA cos theta. Sin 90 minus theta is nothing but cos theta. So total lift, here what we considered, downward direction is negative and upward direction is positive. That is the consideration. So total lift, not drag. Total lift is nothing but FL is equal to integration of tau 0 dA cos theta minus tau 0 P dA sin theta. Or we can write in the simple form tau 0 cos theta dA minus P sin theta dA. So this is the second equation which is telling us the value of lift. The lift and drag, these equations are having integration sign, and generally we are not using that equation. The drag and lift for the body moving in a fluid of density rho, then if we have uniform velocity u, mathematically it is not difficult to calculate if we use the new equation which we want to use later, is nothing but Fd is equal to Cd A rho u square upon 2, and FL is equal to CL A rho U square upon 2. These are the two important equations which we are using in the problem for calculating the FD, that is drag force and lift force henceforward. So in this equation, the concept of CD is nothing but coefficient of drag, and CL is coefficient of lift. And area A is denoted by area of the body, which is which is projected area of the body perpendicular to the flow. So if we know FD and FL, how we will calculate the resultant force? How we are calculating resultant? What will be the resultant? What will be the resultant? FD is known, FL is known, FD is known. How to calculate the resultant FR? What will be the formula?
Square root of FD square plus FL square.
Correct. It is root of FD square plus FL, sorry, FL square, that is FR. So that is the derivation for finding out the drag and lift. This you have to remember. Expression for drag and lift. Funniest thing is that whatever equation you have found, why it is shifting, I don't know. Whatever equation you have found, that is equation number 2 here and equation number 1 here. That is nothing to do with the final formulas which we are using for calculating the FD and FL. These two equations are finally giving us the resultant force. Then moving further, we will see one small problem which you have to solve now with me. I need the answer. So what it is saying, there is a flat plate. Flat plate is there which has area 1.5 meter multiplied by 1.5 meter. And it is moving with 50 kilometer per hour speed in stationary air, which has density 1.15 kg per meter. What is given? CD is given 0.15 and CL is given 0.75. We have to find out lift force, we have to find out drag force, and later we have to find out the power. So it's straightforward problem. I will just explain. What is the area of the plate? 1.5 multiplied by 1.5, it will be 2.25 meters square area. Then u is the velocity, that is 50 kilometer per hour. We required meter per second, so 50 multiplied by 1000 divided by 60 multiplied by 60, which will be actually it is coming 13.89 meter per second. Then FL formula is clear, CL A rho u square by 2. Put the values and find out the answer. FD is what? CDA rho u square by 2. All the things are there. CL is given. Area is also we have found. Rho is also there. U square you can find. And tell me the answer if anyone is doing. Let me know the answer. जर तुमच्याकडे कॅल्क्युलेटर असेल तर. Meanwhile, enter your roll number in the chat box. It will be treated as attendance. Do it once activity. Enter your roll number, only roll number in the chat box, like mine has entered. Yes. Don't add that roll number and other things. Only number, just number. I need number only. And those who are solving, let me know the answer of FL and MD. Who has given the answer? You have to enter the answer. I will provide you a slide, once more slide. Use the previous. Enter in the same where I have given. Enter the answer in the link which I have given, not here. Countdown will start. I will share that tab. Not this. This. Now you will have countdown. $30 we have to finish the lecture. Enter your answers, type your answers in the link which I have provided. 15 seconds. Sushmit and other those who have calculated. It's time up. So these are the answers. It is saying no correct answer, but no, it is. I have not given the answer, so it is saying no correct answer. But correct answer is 187 and 37. 187, that is 186, 187, 37, 32 is wrong, but other things are correct, those who have given the answers. Okay, good. Those who have not entered the roll number in the chat box, please enter it. I'm going to copy that data as attendance. Those who have done with the attendance, they can leave the lecture because this is the last lecture for today, and we will meet in the next lecture. Till then, take care and thank you very much.
Sir, roll number 1.
टाक पटकन मग चॅट बॉक्स मध्ये टाकायला सांगितले मी ऍड इन द चॅट बॉक्स टिल आय स्टॉप द रेकॉर्डिंग. आणि लक्षात ठेवा फक्त नंबर टाकायचे इथनं पुढे, बाकी काही टाकायचं नाही, रोल नंबर वगैरे असलं काही टाकायचं नाही. Now no one will be